Yo guys, Vanity here, back with another tutorial. This one will be giving away the technique or process that made the biggest difference to how I approach mixing. I think you've all probably heard the term reference tracks and may or may not have dismissed them on the basis that they're not directly impacting your mix. For example, it's not a magical compression or equalization setting that unlocks the keys to a professional mix. But for $49.95, I'm willing to give you the one secret to a professional mix. No, I'm just playing. All my secrets are free and always will be. Besides, there is no one secret for a professional mix. It doesn't exist. Not only that, but the only thing that's in your way between achieving professional mixes is you. You have to grow and develop yourself to that level of excellence. You've got to train your ears and put in the 10,000 hours of practice. That's the secret no one's telling you. Not some fancy plug-in or some bullshit product someone's trying to sell you. It's hard work and dedication and thousands of hours of experimenting. Period. I'm by far not the most experienced, but I am learning every day. Hell, the only reason besides enjoying teaching so much that I even came back to producing these tutorials was the fact that the people that were watching them were telling me that they were so dope and they were learning so much from them. I've been producing music for the last 8 years of my life, and I've studied it for 6 years in education, 3 of which were earning an honours degree in the subject, and that's the experience I can teach from. The biggest difference I made to my own mixes came from studying and compiling reference tracks. A reference CD should include a selection of an engineer's favourite commercial mixes, which are used when mixing to provide a benchmark of excellence for a comparison purpose. Comparison, not copying, let me emphasise that. It's very easy for our ears to start playing tricks on us when we've been mixing for a while. These reference tracks allow us to almost reset our ears and are one of the most powerful tools in our producer's toolbox. It's important to remember that these reference tracks contain amazing mixes, not tracks that we essentially like or love. This is the biggest mistake people make when choosing them. So that's my tip. But what I thought would be useful would be to actually show you guys how to study or analyse these tracks and your own records. So I've got one of my own tracks here called With You, and my plan is to pull up a frequency analyzer using Voxengo's Spam. This is free, so you can go and download it from their website. This is what I've got going on. It's actually the introduction track to my videos, so you've all heard that before. The first thing I want to get into is peak and RMS. Now I am making an assumption that the majority of people watching this are not a mathematician or have strong engineering knowledge like myself. So let me explain this term in the easiest way I can. RMS stands for root mean square. The easiest way to understand RMS is that it's just a unique way of finding out the average. Some people suggest that in order to simplify things, RMS should be referred to as average, but technically, RMS is used to categorize the average of a continuous varying signals, such as audio, electronic signals, sound, and so on. The signal can be characterized as having a maximum, minimum, and average. In audio waveforms, this maximum is also called peak. This is measured in dB in digital. In digital audio, the maximum allowable is 0 decibels. If it exceeds this amount, distortion will be introduced onto the audio. Between the minimum, which is the quietest section of the audio, and the loudest section, which is somewhere towards 0 dBFS, the peak, is where the RMS value can be found. Now the reason I'm telling you all this is because it's critical for the success of your tracks. Depending on the genre, the RMS value is going to be different. For hip hop and all urban genres, 10 dBFS is the standard. And remember, this is after mastering. This is where you should be aiming for. So I'll give you a quick visual demonstration of that. If I play this track again, and then keep a little eye on this number down here. So you can see the RMS readout down here. It's sitting between minus 10.3 dBFS and minus 10.7, somewhere around there. The trade-off in mastering is compression for volume, hence the need for professional mastering engineers who are able to squeeze the most volume out without squishing the dynamic range of a record too much. To sum up, the peak value shown here is the highest voltage that the waveform will ever reach. Just like the peak on a mountain is the highest point. The RMS value is a measurement of the average amplitude of audio signals over a period of time. If you're making hip hop or any urban music genres, obviously I can't speak for different genres, you need to make sure that you're getting the RMS to at least minus 10. and again that is after the track has been mastered. The next thing I want to get into is the crest factor, which is just below the RMS here. Now the crest factor is an interesting measurement to me, as I never really see much discussion online about it, yet it is easily one of the most important measurements when analysing and producing a track. In technical terms, the crest factor is expressed in decibels, and it is defined as the level difference between the RMS and the peak of a waveform. However, I like to think of it as the punch of a record. Now one of the reference tracks I use is Like Speed by Dr. Dre. The crest factor on that is insane. It's somewhere around 9, which is really one of the reasons it sounds so good. It is a really stripped back record with minimal instrumentation, so it gives room for the mastering engineer to have a little play. Now if I play this track again and keep an eye on the crest factor this time, it is fluctuating a little bit, but the crest factor on my track here is sitting somewhere around 6, which isn't bad considering it hasn't been mastered professionally. But the main issue with this track is the phase, which I'll get into now. Now the correlation meter, which you can see down here, the correlation meter displays the phase relationship of a stereo signal. A correlation of +1, which is this far right side here, means that the left and right channels correlate 100% and are completely in phase. A correlation of 0, which is the center position, indicates the widest permissible left-right divergence. This is often audible as an extremely wide stereo effect. Now correlation values lower than 0 indicate that out of phase material is present, which can lead to phase cancellation if this stereo signal is combined into a mono signal. So I'll play the track again, now keep an eye on the correlation meter. It is jumping around quite a lot, a little more than I'd like to be honest. Ideally, I'd like to sit it on +1 for the whole time and never move. Even a slight movement here and there would be fine. I mean obviously this is just a guide, it should never hinder creativity, but it does give you some indication when you're not happy about how your mixes are sounding. The next thing is the metering modes, which you can see down here. Now I only want to touch on metering modes, but to really dive into them they would need a separate video, maybe even a tutorial series. Different meter modes essentially meter the audio in slightly different ways. That bit is kind of self-explanatory. But the K metering system, which you can see here, K20, K14, K12, and we've got a bunch of other options down here, is the most interesting, at least in my opinion. Now it's been pioneered by Grammy award-winning mastering engineer Bob Katz. With the K systems, maximising peak levels is not the goal, but instead it shifts your focus to loudness metering and dynamic range. Its goal is to encourage greater use of dynamic range, which I'm all for. K metering even gets into monitor calibration to ensure your studio monitors are set up at the correct levels. That's definitely something I think you should all check out if you're interested in dynamic range and really getting the most out of your records. The last thing I want to touch on is the output meter. So look where my track is peaking at the minute. You can see the peak value down here, it's -0.2. So the output meter is kind of self-explanatory, but there is something that I'd like to touch on that does need to be mentioned, and that is intersample peak. Now to first understand intersample peak, we need to dive into signal levels in the digital domain, more particularly the process of digital to analog conversion. Signal levels in the digital domain are represented by a fixed series of numbers, the loudest recordable signal being denoted as 0 dB full scale, or 0 dBFS for short. When a signal exceeds 0 dBFS, it becomes a clipped waveform with a corresponding set of samples squared off. Now if I lost you there, take a look at this, I've got a little visual demonstration for you. So here we've got a kick drum sample from my selection sample pack. If we zoom right in, we can see how it looks like a normal waveform, like a perfect sine wave with peaks and troughs. Now if I play it, just your standard kick drum, right? Then I've got another kick drum just below it, here. This kick drum comes from a well-respected sample pack company. And can you see the difference between the waveforms? How mine are perfectly round, I'll say. Can you see how these are squared off? Now if we play that, you can kind of hear the clipped audio. Now this is because the waveform has been clipped, resulting in a square off waveform. One of the reasons I've actually decided to produce my own sample packs is to give producers high quality samples, because this is happening all too often. I've actually found that many of the samples currently being released are actually clipped, especially the drums, which later affects the transients of the sound and obviously is going to impact your mixes. Now if I go back to my analyzer, when it comes to mixing and mastering, it's pretty common for producers and engineers to push their final signals right up to 0 dBFS. I'm sure a large part of this is attributed to loudness. Most modern music is created by aggressive brick wall limiting, which will target the peak signals and push the matter right up to 0 dBFS, without the waveform being actually audible clipped. Everyone wants to be louder than their competitor, but at what cost? The problem with running masters right up to 0 dBFS is the assumption that digital signal levels are an absolute, meaning nothing ever exceeds 0 dBFS. However, there's something that's been forgotten. There's a whole area outside of our signal path to consider after we've set our final mix or mastering levels, which is the analog to digital conversion. As it's currently impossible to stream digital music directly into our brains, we have to convert every piece of digital music we listen to back into the analog domain before we can hear it. As part of this conversion, a digital to analog converter has to employ a form of reconstructive filter, rounding off or interpolating the stepped digital waveform and creating a smooth final output. Part of this interpolation process, the reconstruction filters tend to create some small differences in the eventual output levels. Now for a large part of our dynamic range, these small differences are not an issue, but for signals hovering close or around 0 dBFS, even the smallest level change can be problematic. Problems will vary between different grades of converters. Your mix may not sound distorted in the studio, but your peaks could sound clipped on a cheaper hi-fi or stereo system. Now, although it's not explicitly part of the intersample peak issues, it's also worth considering what happens to your mix that has been mastered hot and converted to a lossy audio codec such as MP3. To achieve the desired amount of data compression, many codecs employ various filtering methods to reduce the amount of audio information present, with your lossier codecs usually applying more brutal filtering. Just like the reconstructive filters in the DA conversion process, this codec filtering produces some degree of level discrepancy between the original uncompressed audio and the final data compressed version. The greater amount of data compression being applied, the easier it is for the audio to distort. For such a big issue, the fix is relatively simple. Master your tracks slightly quieter to give space for the digital to analog conversion process. The question is though, how much headroom is enough? Many audiophiles insist that -3 dBFS is the only safe peak level. Others are happy running their masters up to around -0.3 dBFS. Now I'm in the latter camp. While it would be nice to give our tracks 3 dB of headroom to breathe and avoid any clipping issues, it just isn't practical, as the song would sound significantly quieter than everything else. Another option would be more intelligent metering. Now, Ozone's Isotope 7 does give you some interesting options for previewing your track in different audio codecs, as well as being able to solo each codec's artifacts being added to your productions. So I've actually got an instance of Isotope here. If I load it up, so you can see you click on codec, turn it on. Now these are all your different codecs for MP3, you've also got AAC. You can change the bitrate, so this is essentially the compression amount, 320 being the highest quality version MP3 you can get. And then you can also solo the codec artifacts for each one. So the artifacts are essentially what, the sounds and the noises being introduced after compression. So this might be interesting to have a play with, because when you're uploading your track to SoundCloud, obviously they're being compressed. I think it's to 192 actually on SoundCloud. So you can actually listen to your mix in your DAW, how it's going to sound on SoundCloud. If you're losing a lot of the high end or a lot of the bass, you can adjust that and you can compensate for that. It has been suggested that, you can do separate masters for different mediums, but in my opinion, the job of a mastering engineer is to get the track to sound great across all mediums, so it might be something worth having a play with if you're interested in this. But in short though, master all of your tracks to -3 or -2 dBFS and you should be alright. Alright, that's as much as I wanted to speak about reference tracks and how to intelligently read an audio spectrum analyzer. I hope you got something out of this one. Thank you as always for watching and supporting, and until next time, peace.